Hi everyone.
The agenda for today is we'll be seeing basic concepts of network and its architecture. What is a computer networking and what is an OSI model and why an OSI model is important for us. We'll be learning about multiple network devices and understand the network security risk and also the methods and techniques to mitigate the risk in network perspective. First, we go to the computer network. What typically is a computer network? A network, not only a computer network, it's human network, social networking, everything. The word network, it's simply means connecting one or more. It may be one or more computers, one or more devices, one or more routers, one or more monitors, or one or more people. Anything and everything which connects to one or more, those are called networks. In computer networking, we call any computing device which is connected on a network is called a computer network. So the three important factors. The first thing, for any device in a network, any connected device or connected equipment is called a node, which is connected. It's a part of a network. I'll give you some history. So initial days there were multiple product vendors, as like IBM today. IBM even existed before the normal networking started. So IBM were producing devices like network devices. There may be typical older modem or a printer which can be connected on it. Same wise, for an example, HP also manufactures and delivers, and it was used by multiple customers. During the initial stages, what happened was there were no restriction, there were no strict laws or guidelines for manufacturing the network devices. So each company has its own pattern. They designed and developed architecture. They used a specific method to make it easy for the communication between IBM machine to IBM machines. So initially, the machines can be connected only within the manufacturer's end. So it was like HP computer can be connected to only the HP network printer, HP network modem, or specific to that. Same wise to IBM or any other computers which are manufactured will be worked only on the particular manufacturer's interface. To overcome, when days has passed on and the technology is passed on, specific company is not able to fulfill the need of a particular customer. The feature of particular network printer from HP is more good, or it's more required by a person for a end user, but most of his equipments are with IBM. He could not connect the HP printer to his network. This was an issue. The same goes to the if it's a very good IBM machine and the customer uses a HP network, obviously could not connect it and it get it work. To fix it, there was a general body created and they were setting up the rules. They created the OSI mode. Nowadays, any device, any network device follows this OSI mode. So later, just to fix it, any device from any manufacturer can be used on any net. So all the networking devices works on the principle of OSI mode. That is, OSI is just open system interconnect. So it from the name itself we can get it. Openly, any network, any device can be interconnected. And in the slide internet, it's a connection of network which connects all the computing devices and network devices in it. Typically, in a network, we call multiple network segments in it. Personal area network, that is PA and PAN. PAN network is typically your mobile phone and your smartwatch, or your mobile phone and your Bluetooth headset. So these are connected very closely and it belongs to you, and any equipment which you use for your personal environment and it covers a very shorter range, that's called a personal area network. Not only that, Bluetooth keyboard and mice, when you connect to your computer, it connects virtually, but it's also a form of network. We call it as a personal area network. Later, we go for the some more broader range. It may be within the building or within the campus or within the premise, anything between 5 to 50 or 500 meters inside. We call it as a local area network. The local area network, that's a private property or combination of multiple private properties, but they form a single network and a single subnet. The purpose is just an extended coverage of not only your room and just beyond your rooms or just beyond your buildings. Anything which is personal and privately used, that is called a local area network, LAN. And then the evolution of internet grows up. People need to be connected not only within the cities, not only within the countries. They want to connect throughout the globe. Later on, the expansion of connectivity between computers, buildings, and everything within a city is called as MAN, metropolitan, area network. And later on, the wide area network. Wide area network is typically internet. Widely, we connect to any device on any part of the globe from anywhere we are. So, as I sit in India, I can connect to the remote attendees who are from a multiple part of the location, and I can answer any of their queries when they just type in on the question box. So similarly, it's called as a wide area network. We call it as WAN. This image just shows what it is. There are multiple laptops and multiple computers. Behind you can see storage one. We call it as a data centers. We can typically mention in the form of this symbol. And the red bricks, the bricks around the globe, it usually denotes firewall. And inside the firewall, the globe, which is internet. This representation of this image is simply letting know that these computers and these laptops, the data centers, everything are connected to the internet. So anyone from anywhere can access the information from these computers or completely take control over the computers. Let's we move on to open system interconnect. How the OSA model works. It's very basic, it's fundamental, and it's typically required on all the aspects of networking. Not only being a network security professional, even for a basic security network oriented task, we need to be understanding and we need to have a much more clear understanding of this OSA model. So from the slide, we understand what is a layered architecture, why layers are required. In networking, open system consists of 7 different layers. Each and every layer does a task. For a simple example, instead of having a network connectivity, we are splitting the loads and process of networking and the process of communication. We splitted the processes into 7 pieces. Each 7 modules will be taking care of a simpler tasks which were broken, and they are specifically assigned for it. So whenever there is an issue, we can easily identify which layer is not working, and we can directly go there and troubleshoot it. And also by splitting task into 7, each layer are specifically trained and specifically tuned and specifically enhanced over the period, so the functionality of the particular task is getting more efficient. And also when combined, and the combination of these 7 layers gives a good reliability and performance on the network. What is a layered architecture? Layered architecture data sequentially moves from one layer to the other. And also it's a very good point. It moves from one layer to other. Initial processing done by a first layer, the next one moves to the second layer. Likewise, it goes to the third, fourth, fifth, and also as up to the seventh layer. When we start from the physical layer, application layer would be the seventh layer. And likewise, when a user interacts with operating system or when a user tries to Google from Internet Explorer, the user always works on the application layer. Similarly, like how we learned on the kernel level and the application level layer, same works on the networking as well. All the users, any user who tries to communicate over network or tries to search on a Google, try to connect to the go to webinar meeting, try to make an internet call, anything and everything what a user does, that is on the application layer. So when we start from the application layer, the last layer would be physical layer. What does layering mean? Each such operates on the incoming data in predefined way and passes the data to the next level. So each layer is working on operating on how to receive the data and how to process it, out how to send it. So each layer will receive data, process it, and send it across to the next layer. Why does one need layering? So layering also helps breaking a single complex task into multiple smaller units, and each layer can process on the multiple units and get the tedious single networking task done. This is the OSI reference model. As we start from the ground up, the physical layer, this is actually where the physical devices work. You can have the hub or the networking cables were connected to a device. Anything physically you work on it, they are called physical layer. Next, when we move up from the physical layer, it takes you to the data link layer and also to the network layer. The layer 3, it's important for us in security, and also in application layers, layer 7. We'll be targeting on the security on both up to layer 3 and layer 7. Layer 3 devices, we call it as routers, firewalls, IDS, IPS. These can be connected on the layer 3. And on the layer 7, we have the application level firewalls. Those are implemented on the layer 7. So these are the 7 layers of OSI model. And as we said, this is not a proprietary system. So it can be used by any device manufacturer and can be used on any network. So any device from any vendor can be connected seamlessly across any type, any setting of your network. So it should work because all the devices follow only this principle. This slide is a pictorial representation of the OSI model. What happens? The guy who uses a blue shirt on the top left, when he tries to communicate something to the guy on the bottom right who's wearing green t-shirt or green shirt. So over the network, if the blue person tries to send a hi message, the hi message is passed through the application layer and it moves on to the presentation layer, then to the session layer, the transport, network, data link layer, and the physical layer. So a simple hi message needs to pass on through all the 7 different layers. And again, the layer 1 and the layer 3, it's getting communicated. The layer 1 is the modem, your hub, your Ethernet cables are connected, or even if it's a wireless device, which gets connected to the layer 1 device of the green one. So the physical layer, the data link layer, network and transport, session layer, presentation layer, and again the same hi message moves on to the 7 different layers and reaches the green one. Hi, it reached. What the similarity between the physical layer? A physical layer cannot understand what a application layer says. Even when it in the reverse order, same ways, a data link layer cannot understand the language of presentation layer. The session layer and application layer only can understand presentation layer. That too, the data is sent by the presentation layer, but not the data received by the presentation layer. And every layer will have a set of predefined instructions, protocols on how to receive data and how to send data, how to process the received information, how to repack it, how to send it. These are the things. So any data which is origin from user will be originating from the application layer. It should pass the 7 layers below, and again it has to move up from the recipients. The data origination is only from the application layer from any end. For example, if the green person wants to send information, when you send hi message, the same hello message will move from left application layer, presentation layer to the physical layer, and it will be passed on to the other person's computer over the physical layer, data link layer, and moves up and it reaches the blue person. Even if it's multiple people, multiple devices communicating, any number of devices needs to follow the same layer from layer 1 to layer 7 or in the reverse order layer 7 to layer 1. What is a physical layer? Physical layer is anything which communicates, which connects the computers or the network devices physically. The purpose of physical layer is just to convert zeros and ones. Actually, computer understands the language zeros and ones. This physical layer will convert zeros and one into voltage. And again, the same voltage, frequency, whatever we call anything which computer understands to the physical form or the network form. In this layer, we typically work on the wires, connectors, voltage, data rates, etc. This is the very basic layer which makes the networking happen. You could call the modem, network interface cards, hub, whatever network device we connect on the layer 1 hub. A switch is a layer 2 device. Hub is just like a repeater, it connects multiple devices, but it does not have anything specific to work. It's just a connector or a extension cable wherein you use a single plug for receiving multiple power outputs. So hub is also a very basic network device. So it comes on the layer 1 physical layer. After the physical layer, we go to the data link layer. What actually a data link layer is? Data link layer works on controlling the flow of the data and also to identify if there is any errors, if the received message is complete, if the sent message is complete, just to ensure that everything is perfect, has the error detection method. And in this place where we call it as data frames. Layer 3, we deal with packets, and layer 2, we work with frames. Frames and packets are just a smaller size. I mean, broken down information. If the hello message, which carries around 24 bytes or 16 bytes, for example, the packet breaks the hi message into two different packets. So every 8 bytes have a packet, and in this data link layer, it will be further broken down as a smaller segment, and it's in the frame relay. The data link layer provides reliable data transfer via media, physical address, network topology, flow control, and error detection. The networking layer, the networking layer, which is an area where your networks are diverted. This is the place where exactly the computer device, network devices will get to know to which destination we have to move. The layer 3 is also the router we call a intelligent device, which it connects multiple networks. And also the firewall which works on layer 3, it also an intelligent device wherein it knows which network it goes and which network it comes in, because they deal with multiple networks. So this one, they provide the addressing system, they provide connectivity and path selection and also routing protocols. It will be happening on the level 3 network layer. Data layer is furthermore, it will be getting the data broken some more smaller size, and it adds some additional information on it to ensure that the data sent and received will have the complete information. It uses the header and trailer information more to send. The transport layer is the highest layer, just comes up after the network layer. It also ensures that the communication between end-to-end communication or broadcast communication, whatever it is, it ensures the reliability of the data. So this is the one which maintain host establishment or network creation or creating a virtual terminal. Those specific tasks will be taken care by the transport layer. So it also major portion, because the transport layer, network layer, data link layer, physical layer, these are places where the exact data chunks are getting much more squeezed or much more broken down. So every layer will be breaking things into smaller segments and send it to the next level layer. So the session layer is also an important layer in it. It works on the OSI model number 5. For example, I have multiple tabs. The tab 1 is have a separate connection, and the tab 2 has a separate connection. Each different connections are maintained by this session layer. So when I send an information, when I click on this button, obviously it will send a signal to the Edureka server and it will fetch the update. Likewise, for sending the information on this particular session and receiving the information back to the same session is maintained by the session layer. For example, when I see that this is a command, we use netstat following a space and hyphen and a. A means it's all type of connection. The presentation layer. This is the layer where exactly the received data, any information which is received so far, will be arranged in a sequential manner or arranged in the proper way to provide us the exact picture. For example, the slide which I'm seeing here, the letter L will be from a different segment, different packet or different frame. The letter 6, which is completely different packet and different frame, which is received in a different order. So all this information will be coming back to the computer in a very micro or smaller pieces. The presentation layer is the one which collects all the information of the particular session and arranges in a sequential order. So this is receiving the data in any order and arranging in a sequential manner to display it properly to the end user. This works on the presentation layer. So top one application layer, which is on the happening on the very top layer where the user can interact. It is like a user interface to the network where user can use the command prompt where I pinged in type. For example, I can use the ping command, ping google.com. So these are the interfaces. So I'm using a ICMP traffic, and ICMP traffic does not have a port associated with it. It just tries to reach the IP address or the host name. And this is the place where the application works, the WebEx works, Skype works, Internet Explorer works, the web browser works. Anything and everything works on the application layer. So this is how the data flows. Application layer allows the user to access the network resource, and the presentation layer, it translates, encrypts and compresses data. Likewise, when it in reverse, again it decompresses, decrypts and decompresses and present the layer. So session layer 1, which establishes a connection, which maintains the sessions and also management of the session, it will be taken care by the session layer. Transport layer, it again gets the data into chunks, which breaks the data down from the session layer and sends this across to the network layer. In network layer, the data is called as packets, and the packet will have the appropriate heading information, trailer information, along with the destination address and also the sender address. On data link layer, again, furthermore, the packets get broken down and it will be called as frames. And frames, likewise, he tries to send the data as much small as possible. It will get the data to the physical layer, where physical layer typically works on only on the zeros and ones. And those zeros and ones will be sent across to the network over wire or wireless network. This is how the data flows from application level 7 to application level 1. So we need to understand what exactly a data is and what exactly a segment is, what a packet is, what a frame is, and what a bit is. What is a bit? A bit is a 0 or a 1. This is the only language which a computer and a network device understands. 0 is no charge. Number 1 is positively charged. When a positive signal comes in, it will reads as number 1. And if 0 comes in, that's a no. Obviously, there is no signal in it. So these are bits, zeros and ones. Second one is frames. Frame is on layer 2, data link layer. It's a bunch of data created by network communication hardware. So the NIC card, NIC card or router interface, which creates a set of information. This is how frame looks like. It's 802.3 frame format. It's 802.11 frame format. The frame format, it will have the MAC address destination to where the information has to go, and also who is the sender and what is the MAC address of router, second control, access points MAC address. And this is where the payload comes in. Payload is the actual information of the sending word. It comes anywhere between 0 to 2312 bytes. A byte consists of 8 bits. So maximum we can send around 18,496 bits on a single frame. CRC, the cyclic redundancy check, the sequence control, the duration, the frame control. We are sending a single data. The payload, it's a single information. But just to ensure the payload is sending across and received properly, we additionally have this frame control 1, duration 8. The 8 different additional options were added just for this payload to ensure that the data is sent properly and received properly. Likewise, the network packet also will be like this. The Ethernet header, inside there will be an IP header, the TCP header, and the data. The data is the actual payload, the original information what we try to send across or try to receive. This is how the information is encapsulated. So the data is encapsulated into the TCP header, and the IP header encapsulates the TCP, and the Ethernet header encapsulates the IP header. Likewise, it creates a layer by layer. So layer by layer, so that the actual content will be sent, just to ensure 100% it goes to the original state. Segments, it's also the same way. Segment the chunk of data from the session layer. The data received from the session layer will be in chunks. It will be broken down into data streams, and usually a segment is a chop manageable data stream. And data is the generic, normal term what we often use to describe protocols or information, usually from the network layer and up. Any information which is above the network layer are called as data. So this is same as the peer-to-peer communications works. Physical layer can understand physical layer. Data link layer can understand data link layer, but the word is frames. The data link layer can only understand, read and understand frames. The network layer, it's for packets, and the transport layer, it's for segments. And the top three layer is considered as data. This is OSI model. When we see TCP IP model, these three top layers, the session, presentation, and the application layer will be combined as one. And this slide tells you what are the protocols available and what type of devices you can connect to the network. On the application layer, it is usually used for applications where the user tries to connect to the network. The protocols which are used are DNS, domain name system, and NFS, bootp, DHCP, SNMP, TFTP, and HTTP. These are the protocols which works on the application level layer. And the device where we can connect to it is called a gateway. Gateway device are any device which are primarily used for getting communicated to the network. In corporate terms, you might be heard of web application gateway, web email gateway, SMS gateway, password gateway. So gateway is something, any device or maybe application, or it may be a hardware. Any device. Gateway security, it's a primary part where an application level firewall also comes in the gateway category. On the presentation layer, it works on the SSL MIME, secure socket layer, that's SSL MIME, and session layer uses NetBIOS, sockets, named pipes, and RPCs. These are the relay protocols, or NetBIOS is similar to DNS, wherein to identify the resource with the name to IP address or to the IP address with the names. And all these three layers, application, presentation, and session, has the device gateway alone. When we come down to the transport layer, the data is broken and it coming as a segments or a datagram. The protocols used are TCP and UDP. TCP and UDP both are working on the transport level layer. TCP is a connection oriented protocol and UDP does not. UDP is mostly used for broadcasting, wherein when user tries to send a data, the data still flows. It will not care about whether the user received the data or not. In this UDP protocol, broadcasting device or a data transmitter, it sends data as zeros and ones continuously without stopping for anything until all the data is sent. It will not care about whether the recipient received the data or not. Purpose of the UDP protocol is to just to send or throw the data out and complete finishing the data sending across. And it is highly faster. It's used for highly faster communication, and it is used for communicating to multiple users at the same time. Likewise, when we broadcast some session in the YouTube broadcasting, Facebook Live, or any live streaming services use this UDP kind. So the purpose is to just send out the data, not to worry about whether the recipient receiving it or not, just to send the data across. But the TCP, it's more reliable and more stateful. When a packet is sent to the end user, it waits for the acknowledgement whether the recipient received the data or not. And after receiving the data, the recipient needs to acknowledge that I have received the data and this is the CRC data which you sent is matching me. You can proceed to the next level. So likewise, it waits for each and every packet. To make it simpler, this is a three-way handshake. When a data is sent from the computer one towards the left computer is the sender. It's SYN. SYN is the message. I mean, when we capture the packets, we can see that message SYN. It goes here, and once the data is received by the recipient, SYN acknowledged. Message will be sent back to the original sender, and after receiving the acknowledgement from the recipient, it again acknowledges back to the recipient. This is not like logging into bank. Logging into bank is different. HTTP and HTTPS both works using the TCP protocol. TCP protocol is usually waits and for the acknowledgement from the end user stating that he received the communication. The UDP, the sender here, receives a request from the receiver. Dear sender, kindly send. What happens next? The sender will continuously send, no matter whether the recipient receive or not. The information will start flowing just like video streaming service or audio playing service. The data, or when you visit a web page, when it keeps on loading or sending information, the sender will not care about whether the receiver received the subject or not. Once the request is received by the sender to send, it keeps on sending continuously. The data will flow out no matter the receiver receiving or not. But in this TCP, when a sender receives the request, then a receiver needs to acknowledge that the particular segment is sent, is received, and please send me the next packet. The receiver needs to send to the sender, I have received the original packet. Kindly send me the next packet. Or if the received package is damaged or not matching the exact CRC, receiver will send, let the sender know the package which I received is not exactly the same. Could you please resend the packet again? If the 10 packets needs to be sent to the receiver will acknowledge each and every packet. The first packet is good, second packet is good, third packet is good. In likewise, the fourth packet is missed, but end of session, the receiver needs to have 10 packets in his hand. If he misses fourth packet, he'll send, I did not receive the packet number 4. Please send me the packet number 4. Or if the packet number 6 is damaged or it's incomplete, the receiver will notify the packets number 6 is incomplete or it's damaged. Kindly send me the packet number 6 again. So all the 10 packets will come to the receiver's end. He will confirm and verify. Dear sender, I received all the packets as you said, and it's matching all the information you said. So I can proceed it. So the initial 10 packets will be received by the receiver and he can process it. And once again, the connection is then terminates. Until the receiver receives 10 packets, the connection will be continuous and it will not be terminated. Once all the data and all the packets are received by the receiver, the connection gets terminated only after the receiver's acknowledgement. So likewise, again a new request is raised, a new session is established. Likewise, UDP and TCP works. Network layer. Network layer is giving the addresses for a computer or a network device. IPv6 and IPv4. At present, we commonly use IPv4 on most of the devices, and right now, most of the companies are seriously steering ahead for IPv6. Because with IPv4, we can provide IP addresses for only a certain limit of computers. So this is how in this command prompt 172.217.116.78, every three characters inside separated by dot are called octets. Four different octets in an IP address. These are separated by a dot. This is how it would look like. IPv4 address, it will be separated by dot and three characters are called octets, and these consist of 8 bits. Every octet is consist of 8 bits. So totally the size of IP address will be 32 bits, or you can call it as a 4 byte. So 0 to 255, 0 to 255, 0 to 255 to 0 to 255. This is the range an IP address can be. It starts with 0 and ends with 255. And all the octets 0 and ends with 255. There are multiple classes. The class A address, class B address, class C, class D, and class E. This is how the IPv6 address looks like. It will be of total 8 octets, and 4 characters can be in place. 8 pairs of 4 characters. So it will be starting from 0 to F, the hexadecimal character 0 to F. Likewise, in this picture, we can see from 0 to F, that is 16 characters, and also the equivalent binary value. 0 is 0, 1 is 1, 1 0 gives the value of 2, 1 1 gives the value of 3, 1 0 0 gives the value of 4. So likewise, 0 to 16 we can get it derived. I mean 0 to 15, total 16 values we can derive. In the IPv6 table, we can use the 0 to 8 octets. When in comparison to IPv4, we can provide only the binary characters 0 to 255, but IPv6 has hexadecimal characters as well. It uses 0 to F, and also it has 4 different pairs. Likewise, as you see the length and also the size of the characters between IPv4 and IPv6, IPv6 can provide more addresses than the IPv4. Right now, we not only have the IP addresses for computers or for the networking devices. Recently, there were a high trend in getting networkly connected devices, multiple devices. We call the Internet for Things. You can connect your refrigerator, or you can connect your Wi-Fi modem, your air conditioner, washing machine, everything. So each and every device needs to be provided with an address. With IPv4, we cannot provide a lot of public addresses due to the scarcity. We almost migrating to IPv6, wherein it can be obtain multiple addresses. So on the data link layer, what we deal with? On the data link layer, we're dealing with frames. Frames also a smaller segment of datagram or a packet, and the protocol used on it were Ethernet, IEEE 802, LLC, IEEE 802. So the term IEEE you should be hearing more on the computer field. IEEE is a standards organization. They were the people who design or who approve the connectivity methods. They are the one who design the USB cable types and USB sockets, the firewire, Thunderbolt cable. So this is the Institute of Electrical and Electronics Engineering. They are the people, or they are the body who prove and develop technologies for communication. For the security, as we see that NIST, we see the NIST frameworks, the NIST technologies, I mean NIST procedure and features. The IEEE is exactly the same, but they work much on the technology and engineering and communication part. They design and they approve, they permanent the Wi-Fi, the next generation 4G, 5G, any networking or any technology oriented, it comes only through IEEE. The physical layer transmits the zeros and ones. We deal with bits on here, and also the protocol is used is IEEE 802.2 or ISDN. The devices which we connect is a repeater or a multiplexer or hub. What is a repeater? Repeater is nothing but a extender or a signal extender, or it usually signal extender. Hubs also does the same thing. The hubs will not have the MAC address. A MAC address is actually what we call as a burnt in address. An address cannot be changed. Computers and other devices, we can have multiple addresses. One is a static IP address or a dynamic IP address. Static IP address, which is permanent and it will not change when you reboot your computer and when you restart your computer, or when you're not using a computer for almost 10-15 days or a month or even a year. Your IP assigned to your computer will be static and it will not be changed anytime. Not only for a computer, can be also for a network device. Static is permanent. Dynamic, we can change, or whenever a reboot happens or whenever we need to switch a account, we can change the IP address. You can get a new address. So the physical address, the MAC address, which is created while manufacturing the device and it hardware built. I mean, there are multiple capacitors which will be burned down when manufacturing. This is how the MAC address looks like. 3A, 34, 352, 6C4, 69. This is how the MAC address looks like, and these MAC addresses are embedded on the network device. This is a network interface card where you can see the MAC address is printed, but actually it is not like a printed one. It will be like a burnt in address. They'll be burning down few sockets just to make sure the particular value will not change as they make the IP address hardware level. It's not on a software level. So the physical address will not change. And this is how it's an example of your network interface card looks like. This seems to be like an older card. The newer card will have multiple sockets, or a single network interface card have multiple Ethernet ports, or nowadays it's more advanced. This is typically how a network interface card and the MAC address looks like. The demo one. So demo one, what are we doing is we going to download a packet sniffer. Packet sniffer is nothing but capturing the data on layer 3. It grasps the data which sent to the network or received over the network. So this is the time we need to download trial software on the computer, and we need to go for a demo session. So once I fill in the form, it asks me to verify the email address. Once we fill in the form, we'll receive an address. I'm copying the link from my address and entering it here. When we fill in the form, we'll be receiving an email with the download link. So it will take you to the download instructions page. It's valid for 30 days. And this is the serial number. You can click on the download trial, save the file. File size is around 300 MB. I'm running the file which is downloaded. Next. So it requires an internet connection. It is not accepting email. Instead, you can use the link which I gave. So when you click on the link, it will also give you the serial number, which is a 30-day serial number you can use. It's automatic. When you click on automatic and click on next, here I need to put in my serial number and proceed all the information. So there is a one more wonderful tool. Wireshark is a wonderful tool for packet capturing. It's a 100% free tool, open source. And what I would suggest is you could also go to the Virtualbox site. So when we have a computer, we can install multiple guest operating system using Virtualbox. This is the place where you need to go. You have to download Virtualbox. I'm using a Windows host. So I click on the Windows operating system. It will download a setup file, which is around 109 MB. I'm also downloading the Virtualbox setup extensions. So right now I'm downloading a tool which is called Virtualbox image for Kali Linux operating system, which is dedicated. This is used by all the offensive security professionals who work on testing application security, network vulnerability. It comes with multiple built-in tools. Tools will help us to get fixing the bugs or fixing the vulnerabilities. So after downloading the VirtualBox, we need to go to the location here. It's offensivesecurity.com to download Kali Linux and select the Linux VirtualBox image, not the VMware image. We are using VirtualBox, which is free from Oracle, and we can run multiple operating system on it. So I'm downloading the 64-bit, and this is the link for 60-bit 4-bit operating system, save file. I don't need to download Wireshark on the same one because as it comes along with Kali Linux, use this link for downloading. I'm running it. Click on install. Yes. So the installation is running. Asking for a serial number. This is the serial number. The other two applications, which is an Oracle VirtualBox and the Kali Linux image, does not require serial number. It's 100% free. The next thing what we do is we can just double click on the Kali Linux image, which we downloaded from Offensive Security. Let me go back. In the meantime, we come back to the Omni Peak. I click on the new capture, click on all the adapters. So I'm clicking on the start capture. So it should be capturing all the information. If I type in Google or something, google.com packet capture test. Look, there were some traffics identified. It also capturing my RDP. RDP is nothing but remote desktop protocol, where I used to connect to the server which I'm working on. Is I got connected from my laptop and it's hosted on a cloud environment. There were a traffic identified which is on google.com. So totally around 3,12,900 bytes captured on this session. So it's still monitoring the network activity. Let me give you an example what a streaming would be. Let's play Aladdin. Aladdin is playing in the background. The Omni Swipper is already started capturing. Do you see that Google.video? It's raising. The network is speaking here. So let me stop capturing it. These are the HTTPS traffics. Let me go close. On the total traffic, the top protocols used, it's for HTTPS. 68.5% of my traffic originated and received on my computer. It's HTTPS. Almost close to 70% it's used. And the remaining 30% it's used by the remote desktop protocol, which used to connect my laptop to the remote server. On the left, there were the high percentage of data used by youtube.com, which is on 34%. Google has on 10%, the others as well. So application wise, we captured YouTube 63%, RDP 10%, Google Video other 4%. The streaming media, it's around 67%. Toward the left, there is no voice and video call, the no compass. We see the packets here. This is how the packet looks like. We captured an RDP packet. This is how it's the packet info, the number of flags, the status, the length of the packet, and the timestamp when it's sent. As we seen on the previous picture image on how the packet looks like do you see the destination? This is a MAC address. This is also a MAC address. Protocol IPv4. IPv4 header also has information on it. Header length. So they identify the fragment ratio. So this is how the packet looks like. The packet information packet head. And this is what actually streamed across. 42010A. This was the information goes through the network. This is how you see when you capture a packet. So when we go on a packet, so why don't we see the YouTube video? This is the Google video application. We captured something. We captured it from the Google video. Again, it shows the hexadecimal alphanumeric characters. This is of obviously no sense when we capture it. But that too, in encrypted traffic, we would not be able to identify what exactly sent across the network and what that is. For simpler, let me start capturing one more thing with the HTTP. I mean, HTTP without encryption. Let me find a site because nowadays all the sites are becoming HTTPS traffic oriented. Save changes, yes. This is my capture one. Resuming capture two. Let me open up Wikipedia. That's also should be HTTPS. HTTP website. BBC is that HTTP? BBC seems to be HTTP, but not sure whether it would work. Let us capture again. That's a boxing happening. We have a HTTP traffic here. So let's stop. HTTP traffic captured packets. We need to scroll down and identify. Let's filter HTTP. Now we see the HTTP traffic. We filtered out other traffics. So we can see only the HTTP traffic. So when compared to the older string, we can now read at least on the towards the right, you can see unencrypted text. Do you see my mouse pointers? We can read text, access control origin. This was the web page goes here. When we read something, this is the character set, header information, allow access control. So when compared to the previous HTTPS traffic, HTTP traffic can be read. It can be easily decoded and we can identify what goes and what comes in the packet format. This is a simple example how we captured the network traffic and we intercepted. TCP/IP. The only difference is the top four layers will be converted as a single one. This is the regular TCP/IP model. The network layer, the data link layer and the physical layer both are combined. Network access network layer. Data link layer and the physical layer are single, the network access layer. And the OSI model network layer will be called as an internet layer and transport layer will be host to host. And the top three layers of application, presentation, and the session. These three will be combined and will be called as a process layer or as an application layer. This is the difference between TCP/IP and the regular OSI mapping. So simple TCP/IP stack. What are the protocols used? Top four layers. The application layer uses FTP, SMTP, Telnet, HTTP, etc. And the internet layer uses host-to-host layer uses TCP, UDP protocols, and the internet layer uses IP, ARP, ICMP, and the network layer network interface. These are the simple examples. What is an FTP? FTP is simply a file transfer protocol. It helps us transfer file between share a file from a server or to store some files on the server. Telnet is a remote logging protocol. It helps us to log into a computer remotely. SMTP is a simple mail transfer protocol which helps us to send emails. HTTP is hypertext markup language, HTML, and it uses HTTP protocol, hypertext transfer protocol, for the internet purpose browsing websites. Any website you see on the browser is created using HTML, CSS, JavaScript. The backend scripting like PHP, ASP.NET, JSPs, anything. But the foundation for building up a web page, it's HTML. So it also uses the HTTP protocol. So these are the difference between TCP and UDP protocol. It's a stateless. So where we use it, UDP is usually not meant for reliable. It's not meant for reliable communication. It is used for real-time application such as VoIP, online streaming, etc. It is most used for unidirectional. It's for one-way directional. Once from a receiver to the senders. That is how it works. It will not work from the two-way handshake or two-way communication. It's single-way transaction. Wherein the TCP, it's more reliable and more connection oriented, and data sent across the network or received across the network will be reliable. Difference between IPs V4 and V6, we already seen that. IPv4 is a 32-bit address, wherein the IPv6 uses 128-bit addressing scheme. Approximately number of address available on IPv4, that seems to be almost close to 49,67,296, almost 420 crores. Even though the amount is vast, but we cannot use it on multiple computers. It is not sufficient enough to assign it to all the clients. Likewise, we got into the other address IPv6, it's 128-bit addressing. So it's approximately 2 power 128. The IPv4 address is just 2 power 32. But in IPv6, it gives 2 power 128. So it's too large. We get multiple addresses, billions of address we can use. The ARP, we use this address resolution protocol. It's one of protocol used to identify the network devices and to get registered on one of the network. BGP is border gateway protocol. It's simply a routing protocol between the networks. It's BGP. It's highly used. Let's go for one more demo on IP Watcher. Downloading the IP Watcher 3 and running it. I'm going with the trial evaluation edition. IP Watcher is a freeware, supports 2000 XP. In this case, my operating system is 2012, so I need to run it on a compatibility mode. Go to properties, compatibility. Instead of running compatibility, you can select Windows Vista or Windows XP. Let me try running as Windows XP. No, it's not working on my computer. This is just to test the IP. For testing up the IP, we can also use the command prompt nslookup to identify whose IP it is. We call google.com. We'll get the IP address here. This is the IPv6 address, and this is the IPv4 address. So likewise, we can also go for yahoo.com. It will give you the IPv6 and IPv4 addresses as well. I'll try to reverse it up. 172.217.166.78. This is the IP address we got from google.com. I'll give this address here. This is the place where it's hosted, 72.30.35.9. When we reverse it up, this takes to the host name of the Yahoo server. So likewise, we simply use command line tools. We use ARP, the same address resolution protocol, 72.30.35.9. So when we run our address resolution protocol, it will give us the locally available interface, locally available networks, IP address, etc. Likewise, the command prompt which comes with Windows operating system has multiple utilities that can be used effectively. So instead of going for a freeware or downloading additional softwares, there is various tools which can be used in command prompt. And from Windows 10, I mean the server operating system and other has PowerShell, which is more powerful than command prompt. which got multiple utilities and multiple functions. We can use scripting, we can program, and we can write a script to automate things. More advanced and more complex tasks can be easily achieved using PowerShell. So I'll type power. The regular PowerShell would be like similarly this. It is similar to a command prompt, but it's more powerful. But for creating the scripting language or creating some automated task, you'll get the panel here where you can get the syntax. It's similar to the syntax. You can use the assistance from it. These are the list of commands here available. Get instance or add history. So easily you can create the command. You can use the PowerShell here, import module. So when we are getting the modules imported, the storage or history option. So likewise, we run some command PowerShell network script. So when you get into the internet, you can see multiple scripts here. Let's copy and try running it here. This is an example. It just calls the get services and running services on the system and it displays. So most of complicated tasks on the computers can be automated and it's easily achieved just by running a single line or multiple lines of scripts. So no need for us to go beyond. So again, the data encapsulation. Data encapsulation, what we see on the picture, one layer is encapsulated with other information. Data encapsulation I show you as in picture. Data encapsulation image. What we see on the application layer, does the image, this is how much I can expand, maximize. This is the data. On data layer, you see the data. When it comes to the transport layer, it uses the protocol UDP and the data and encapsulated with the UDP header. Data becomes a UDP data along with the UDP header, and the same amount goes into the network layer as a IP data with the IP header. This is called encapsulation. Every layer the data passes through, it adds additional header and trailer information along with the additional information added on the previous layer. It comes to the next layer. So on the IP layer, it also adds a IP header field along with the regular data and goes to the frame layer. In the frame layer, what happens? The frame header is added to it and also the frame trailer added to it. Typically, when we see two-fourths of the data is the original data, the remaining data are created while it passes through multiple layers. This is called data encapsulation. So these are the common devices what we see on network. What we see as a repeater. Repeater is simply an amplifying device. What is the difference between a bridge and a repeater? Bridge also does the same thing. It is a pass-through device. Any network can pass through it, just amplifies it and retransmit the same signal. But the only difference is repeater does not have a MAC address, but a bridge does. The repeater, the hub and router, gateway, switches, and most of the security networks are missing in the slide. The firewall, IPS, IDS, IPS is intrusion detection system, IPS is in prevention system. These are all missing on the slides, but it's good for us to know them better. Repeater works on the physical layer. Repeater is just amplifies the signal and sends the distance to a longer length. And hub, data link layer. The difference between the repeater and the hub is repeater amplifies only the particular signal, wherein hub gets signal from multiple inputs and send it to a single output or multiple output, or receive from multiple input and transmit across multiple output. Different types of hubs are active hub and a passive hub. The active hub is typically just to clean up the network disturbance or network noise and also to enhance the signal strength across the network. So the passive hub is simply a pass on the device. It just transmits the signal whatever it gets. It will not make any modification or error fixing or denoisification, etc. Bridge is similar to the repeater and has the ability to filter and require content based on the MAC address. Router, it's a very important thing. It works on the layer 3 and it is an intelligent device wherein it can make communication between two different networks. The switches, hubs, the repeaters, this works on a single network, single subnet. It cannot communicate between networks. But the router, it's an intelligent one. It can communicate between multiple networks and also can route traffic between multiple networks. The session layer works from network layer till 7 application layer. It actually maintains sessions of every individual connection. Every single connection has a session that was managed by the session layer. Presentation, the switch also works on the data link layer. Network protocols and security viewpoint. What is a set of instruction? A protocol. A protocol is nothing but a set of instruction on how to move data between a device to a device. So OSI model is the fundamental which makes any device from any vendor can communicate and connect to the other network. Typically, it uses a headers and trailers so that it be easy for the data to be sent from one layer to other layer and to move across. The ARP is address resolution protocol. So in attacker's perspective, we can see how an ARP can be manipulated. ARP packets will be sent across multiple devices, not only network devices and also from computers. So ARP request is sent from computer one, the hop to the computer two. In between, there is a switch. Also, we can see a person who's monitoring the traffic between the switch and the other computers. What happens when attacker manipulates the traffic and manipulates in producing a different address and different cloning of IP address or MAC table? That's also called as an ARP poisoning. As per the attacker's view, there are four different things that taken care. One is subnetting, local segment. Previously, what we dealt with the personal area network, local area network, and wide area network, etc. Subnetting is even a smaller fragment of any of these network, PAN, LAN, WAN, any etc. And the attacker also can obtain the encryption information. So how the encryption works and how it's got. When the ARP was poisoned, even the intrusion detection system can be bypassed, and that's obviously a security breach. DHCP is simply a dynamic host configuration protocol. Previously, we were discussing on what is a static IP address and dynamic IP address. In environment of more than hundreds or thousands of computers, it is obviously hard for an individual to go to each and every computer and to assign a IP address. So just to overcome, DHCP service is enabled. What actually it does, it provides a IP address to one of your computers. It can be configured to set particular computer with a static IP address or with a dynamic IP address. DHCP service is usually for managing and maintaining your IP addresses. In operating system like Windows 2012, we can find the DHCP server here. So I don't have the DHCP configured here. For it, what I'll be doing is I'll be adding in the server manager. I'll go there, a role-based feature on the same here. So I'll be promoting as a DHCP server. So when I click on here and next, we can also add additional features which are to be enabled. Let me can try install the telnet client. So as of now, DHCP is enough for me. So when I click on next, it will ask whether I need to proceed, and confirmation when I install, the DHCP server will be installed on this computer. The only thing I need to install and reboot the computer. So DHCP comes along with any server operating system, or we can also download free DHCP servers. If you're using regular operating system like Windows 10, Windows 7, Windows 8, we can go to the SourceForge and use OpenDHCP. OpenDHCP is a free application where you can run it on your Windows operating system. It can take care of assigning the IP DHCP task. So what a DHCP point of view an attacker looks in. Attacker also spoof into the network. Once he gets the access to the default gateway, he can obviously spoof into the any traffic comes in and going forward. He can manipulate the man in the middle attack or denial of access service. For example, I'll again go with the command prompt. We can take google.com as our DHCP server. What I'll be doing is I'll use the switch hyphen T, which means it will be continuously pinging. So if I did not use the T, it will ping the host for 4 times and it gives the result. But instead, I'll be using an hyphen T to ping the host address continuously, repeatedly. It means that it will be sending a traffic or sending a request directly to a DHCP server. Likewise, I can open one more instance, duplicate instance of it, command. Again, I'll use a ping and google.com makes hyphen T. There are two different computers. For example, these are two different computers running a denial of service attack. So what happens when we use one more thing, google.com hyphen T? It means that three different computers are trying to send requests continuously on a DHCP server, which means the DHCP server will be on load. It needs to be processing all the input requests. When a hacker is into a network, obviously he will not work with a single computer. He'll be having hundreds and hundreds of computers which are bots. Bot network is typically which is an infected computer which would be controlled by a hacker. When hundreds of computer tries to perform a ping test or a request to a DHCP server, obviously the DHCP server will not be working fine and it will be down for some time. In the meantime, DHCP cloning attacker can be gaining access, or he might temporarily be a DHCP host as we shown here. when he has compromised computer installed with the DHCP host and configured it to a DHCP, with the DHCP server, he can also run a domain name server, so he can poisoning up DNS, which makes any computer from your corporate network to redirect to a wrong traffic. For example, when a user tries to type in google.com, it should not go to yahoo.com. It should obviously go to Google. But a hacker can manipulate the traffic and redirect and take it to a competitor site. By bitcoin.com, you should go for bitcoin.com. It should not go to the any other ruble or cryptocurrency, other coins, obviously. So the traffic manipulation and the DNS poisoning and R poisoning, these are so crucial in the network level security. ICMP, what we did, we just pinged. Ping is ICMP, Internet Control Message Protocol. It does not use as a proxy. It just tries to reach the IP address. The same ICMP, based on the ICMP, we use the Smurf attack. We use multiple packets. We can customize the ICMP packet and send it across to a particular destination. Every layer, every packet sent to the layer would be understood only as content, only when if the format is valid. If the wrong format or malformed request comes in, particular layer will not be understanding it, and it will not know how to avoid or how to process the things. Obviously, when we flood hundreds and thousands of packets with the malformed data, usually the network device or network service will go confused, and it will make a temporary network unavailability. So these are the ways we can modify the packet, malform the data, or malform the strings, or malform the content, and send it as a ICMP. One of the common way, it's a malicious script, browser-based attack. A script will be injected to any of the trusted website, and the infected script will make the website behave malicious, or it can divert to a different system or something. Denial of service, distributed denial of service, these are things which making the services not available for a certain time. Usually the hijacked website or script manipulated website or dom based manipulation, which are done just for the personal gain of the hacker. They obviously use email campaign, where we'll be receiving a genuine email. When we click on a something particular link, it will take us to a malicious or infected site. It will get advertisements which is not specific for us. Also, it will take us to get the malware or malicious software download into the computer. Ransomware campaigns like WannaCry, Petya, etc., the crypto lockers, these were used campaign. The malware campaign done through phishing emails or on the fly downloaders or traffic manipulated. We intended to visit the right website, but it was diverted to a wrong website and getting the malware downloaded and getting ourselves in trouble. So those were happening in the previous past. So make sure that you're not clicking on any of the phishing mails. If you suspect the mail is not from a trusted one, simply delete it and don't explore the email links and try to get yourself infected. Always have a good antivirus running and keep the definition of signatures, the software upgrade of the antivirus up to date. In my computer, I do not use antivirus because most of the time I use some specific tools, which would be the security auditing tools, which similarly simulate infection malware. So those tools will be blocked by antivirus and I would not be able to work. So that's why the reason I will not use antivirus on my computer. And also what I do is if anything goes wrong, I'll right away go and reset the PC. I'll wipe out the data and reinstall. I will not have important stuffs on it. It is just for a testing PC I have. And other three common one is cross-site scripting. Cross-site scripting is inserting the infection or inserting the script or any piece of online application, online website, and making your custom script work for you. And the SQL injection is identifying the values or schemas of the table you use. Mostly people use SQL, NoSQL based database for creating your web page. Any large web page which is maintained by CMS or database oriented, most of the web programming language support SQLs. So using the SQL, not only the vulnerabilities when you are so experienced in SQL queries, a string, customize writing a string and send it across. Usually on the address bar, you can see the tab. This is the URL, and following which there is a query string which starts with a question mark. And I use the tab equal to course content and other batch ID equal to 1820. So usually with the string, I can manipulate, I can custom create a URL and send it to it. So path traversal is also simply navigating into the sites, just like moving into their web directory or local directory. So physically triggered attack, some rogue devices. What happens when person comes and connect a device on your local network? That can be any device, a router, switch, a computer device, or even a network sniffing device, which got connected to your network physically, and it also becomes a part of your network. The scanning network, the port scanning, vulnerability scanning, the same picture explains the same. There is a hacker who inserts his hand and gets access to the local computer. It's list of ports open. The vulnerability scanning. Vulnerability scanning is scanning your computer for existing vulnerabilities or known vulnerabilities. You come to know that these are the existing vulnerabilities available. For example, we go for a Nessus scanner. Nessus is a freely available tool. It's a vulnerability scanner. You can also use a trial version of it. Nessus scanner, like with Map and NCAT, these are very important tools. I'm giving an 8 gigabyte of RAM for the virtual machine, and I'm also increasing the processor. Once we got into the Kali Linux box, we can see some additional stuffs. I mean, how to use Nmap, how do we use Metasploit for scanning the vulnerabilities. APTs are advanced persistent threats. Advanced persistent threat are more complex, or they were like a masterpiece of virus. If a virus or trojan or a worm, it's like a high school kid. The APT levels are like they are a doctorate level programs. Just to identify the presence of the infection, it takes time. So before we identify, it comes in, it does all the tasks and activities it intended to, and it also keeps itself deleted, or it keeps it traces.
Thank you.